Okay, more about the parabola. So we're going to investigate this using table of values and draw them and see what effect it has, the number in front of x squared, have on the parabola. You probably know what they do, but let's investigate it using table of values. So for the first one, we substitute -2 into x squared, so it's 4, then multiply by 2, you get 8. Does it make sense? So basically, when you have a 2 in front, it doubles all the previous values. So you double that one, double 0, double 0.5, double 1 is 2, double 4 is 8. Okay, so you got all of that. Okay, so what if there's a negative? Means all the x value, all the y value become negative. -1, -0.25, 0, -0.25, -1, -4. Okay, so we're going to draw this. Maybe I should use a different color pen so you can see the differences. Okay, so what I'll do is I'm first going to draw the standard parabola x squared first, so you can see what it does. Alright, so let's draw the x squared graph here, here, and here. Okay, so that's normal x squared graph. Oops. Over here, and what else is 0.5 here? Oops. Okay, so that's your graph for y equal to x squared. Okay, so that's your graph, y equal to x squared. And then what we do is we're going to draw 2x squared using a blue pen so you can compare them. So when you have a 2x squared, everything gets double. Double here, double there, and then there, and then there, and then a little bit higher, a little bit higher. Okay, cool. Alright, so you draw this. Oops, that. Okay, good. So something like this. So you see the graph gets more narrow when you double the x squared, right? When you double the x squared, the y value gets higher with the same x value, therefore making the parabola more narrow because it gets taller. When stretch it in the vertical direction, it makes it more narrow. Okay? Alright, and then what we do is we drew this one. You also have to draw -x squared. Let's draw -x squared. I'm going to use a different color pen. Maybe use a blue one. Actually, maybe I could just highlight them. Does it let me change color? Let me see. Let's change it to purple. Oh, it works. Good. Alright. That's good. I don't have to rub off. Okay. So I'm going to draw the other one, -x squared, using purple. So we'll plot the points. Over here, there, there. So you see, you got this parabola. Okay, which is y equal to -x squared. So now you see what the numbers does to the parabola. Okay, the purple one, the -x squared makes the parabola concave down. The 2x squared, the 2 makes the parabola more narrow. Okay, more narrow. Okay, all right. Take a minute to think about this. Remember these effects on the graph. And if you want, you should also draw another one. Let's draw one with y equal to half x squared. It's going to be more narrow if the number gets smaller. So let's try to do that half x squared. It gets half of the black one, the black parabola, like this. So it gets more wider. So the smaller the number, the wider it becomes. Actually, the bigger the number, the more narrow it becomes. So you see the effect. Okay, and the negative makes the parabola concave down. Right, draw this please, and then we're going to do more investigation in terms of the shifting of the parabola, and then we'll come up with a general strategy to learn how to draw them. Okay, right, if you're still copying the table, I will leave it up there so you can see. Okay, there you go. Hopefully you're all finished. When you're finished, we're going to do more table of values on the next column, where you get to investigate the effect of having a +2 inside the bracket or outside the bracket. And then we're going to come up with a general formula. Okay, all right, let's try to do that. So again, you can use your calculator. So that's given. So if I do +2 means I'm going to add 2 to the 9. So you get 11. Add 2 to the 4, you get 6, 3, 2, 3, 6, and 11. Okay. I'm going to draw the O1 on there so you can see. So let me draw the O1. O1's like here, there. Oh, wrong place. And then we have 3 is 9. 3 is 9. Okay, so got this here, got this there. Okay, that's the original y equal to x squared. Okay, that's the parabola y equal to x squared. And then what we're going to do is to draw the blue one, y equal to x squared plus 2, and see the effect it has on the parabola. Okay, let's do that. So we're going to add 2 to the y value. So you get, so you add 2 units. So here, here, here. And 4 plus 2 is 6. 6, and then 9 plus 2 is 11. And then get these points. Oh. Okay, that's your parabola. Y equal to x squared plus 2. Okay, and you will see the graph has been moved up 2 units because all the y value is added 2 units. Okay, so you see there's a gap. There's a gap, 2 unit gap. Okay, 2. Right, there's a gap. So every point you choose, there's a vertical gap of 2. Okay, so you've been shifted up 2 units. Every y value. So end up the graph being shifted up 2 units. Okay. All right. So after you do that, let's see what happens. What if we do x minus 2 inside the bracket? Let's see what it does to the parabola. So we have to do some substitution. So we're going to use a green pen. All right. Let's look at the. So what you do is you can't rely on 9. So you have to substitute -3 into x. And let's do that on a calculator. So put -3 into x. So you go bracket -3, right? -3 into this expression -2, close bracket, square, equal 25. 25. Okay, and do another one. I should get rid of the start mode. Okay, let's try. And the next one, bracket -2 -2. Close bracket, square, you should get 4 square, which is 16. 16, like that. And then the next one is -1. You should get 9. And then what else? We just keep doing the same thing. 9, so 0. 4. And then put 1 in. 1. Yep. Huh? Huh? Alright. Yeah. Yeah. Okay, I have to stop recording. Continue. Sorry about that. Okay, good. So we keep going. You get 1. And then, of course, maybe if you use your calculator, you can finish before me. You get this thing. And let's plot the points. Now, if you look at it, let's compare this row. Highlighted. Let's compare this with this. Yep. Oh, sorry. 0. Yeah, it should be 0. And what else? Oh, wrong pen. 0 and 1. Okay. Alright, 0 and 1. Okay, now is it correct now? Okay, it's correct. Thank you. Alright, so if you compare, what do you see about the y value? It's been
shifted
to the right, isn't it?
right.
See, the 1 here goes here, the 0. Actually, I've got the magic pen, which I could use. So you can see it's going to go that way, that way. So it's shifting right, isn't it? So let's plot these points. We're going to go pen, green. So you end up getting this thing. Okay, that's your graph. Okay, you got that? And then you will see that the graph has been shifted to the right 2 units. 2 units. Shifted right 2 units. Okay, so we go this. Okay, yes? Any questions? So we see the effect of +2 outside the x square and the -2 inside the bracket square. What effect it has on the parabola. And we're going to make a general statement. And then next time we don't have to do a table each time. We can just work out very quickly. So we've done this graph. The next page we're going to write a summary, and then we're going to draw some graphs, and then we'll do more graphs on the next page. Okay, all finished? All done? Thank you. All right, next page. So next page we're going to write down some conclusions. So we learned that the following: when you add an h to x squared, you shift up h units. Right? And when you go -h, you will shift down h. And we see that when it's a -k, you go right k units. Right? And if it's +k, you will go left k. Okay, good. So you got this bit. And then, yes? Alright, so this is the -h outside the x squared, so you go down. So the vertical bit is the stuff outside the x squared. The horizontal bit is the stuff inside the bracket. Okay? Continuing on, we also learned that this A gives you the shape of the parabola. When A is positive, it's concave up. When A is negative, it's concave down. In addition, if A, the bigger the value of A, the more narrow it becomes. So, ran out of space. Maybe I'll write it. Oh no. So if A is the bigger the A, bigger A, more narrow. Okay, smaller A wider. Okay, so these are the effects. So remember what each of these terms, the effect it has on the shape and the position of the vertex of the parabola. And then now it comes to the general form. So in general, this is the part that you look at. We have to see that H is the vertical shift, which can go up or down. And you can see the K is the horizontal. And the A gives you the shape and the concavity. Shape plus concavity. So there's 3 important parts of the parabola. The horizontal shift, the vertical shift, and the concavity. The concave up or down, and everything else. And the narrow or wider. Okay, good. All right, once we do this, we're going to do example 1. Let's look at this graph. So we have to answer a few things about the graph. Sketch the following quadratic relations, labeling the turning point and the y-intercept. Okay, now hopefully when you see that, you know that this parabola does not move up or down or left or right. It's just a parabola through the origin, and the 3 will make it more narrow. So how do I show the narrowness? You will draw a little bit narrow, but it's hard to show. So what you do is, you substitute x equal to 1. When x equal to 1, what's y equal to? 3. So you just show a point on the parabola. That's enough. Okay, so to distinguish that from the other parabola. Substitute a point. I think that's all. Pretty simple. And just write down the turning point. So write turning point, which is the origin. Turning point is origin, 0, 0. And the y-intercept, where does it cross on the y-axis? It just crosses on y equal to 0, right? This is the y-intercept. So the vertex is on the y-intercept as well, okay? All right. And there's 2 more. You could have a try. That's an easy one. All right, try the other one when you get a chance. All right, good. All right, hopefully you're all done. And we're going to move on to the next question. Have a try. Let's see what it does. Whether it shift up or down, concave up or down. Okay, all right. So let's move on to do the next one. Next one. Okay, so hopefully you can see the structure. Negative x squared plus 4. What does the plus 4 do? You shift up 4. And what's the concavity? The negative means it's concave down. Right? So we'll just have to, maybe I'll use a magic pen. So you draw a concave down parabola, which is negative x squared, and you're going to shift up 4 units. So you end up drawing here. Right? Okay, good. So it just disappeared, which is good. So now I could draw it properly. Let's get my pen here. Okay, good. Right, so it's going to shift up here. Up 4 units, so it's going to end up at 4. The y-axis and the x-axis. So you have to show the vertex, which is equal to 0, 4. Okay? And what else you have to show? The y-intercept. Y-intercept. Now the y-intercept is just simply 4, right? Crosses the y-axis at 4. Continuing, we're now going to go through. Now before I continue, the question didn't ask for x-intercept, but it's good to find out what they are, and it's not hard to find out. Yep. Yeah, so how do you work out? You put x, y equal to 0, see what equation you get. You get 0 equal to negative x squared plus 4. Now how do you solve this? Move the x squared to the left side, and you square root. But make sure you put plus or minus. So it's 2, negative 2, and 2. Get it? But you should know how to show the x-intercept on the graph. Okay, there's one more. The next question, have a try, see how you go. All right, try the next question. I've shown you everything. Try the next one before I do the harder one on the next page, before you do the exercise. Okay, good. Try the next one. X plus 2 squared. So what do? What does the plus 2 do? Shift left 2 units. So it's going to go like this. Y and x. Now write down the vertex, which is equal to negative 2, 0. And what else are there? You have to show the y-intercept. So this one you have to figure out by substituting x equal to 0. So x equal to 0, which is x equal to 0, and you get y equal to 0 plus 2 squared, which is 4. So you can show 4 on the diagram. I think that's all. Okay, good. Any questions? Pretty easy. Okay, good. Once you do that, once you know how to shift things, we can now draw other bits, like the next page. So there's more questions on the next page. Have a try. I think you should be able to work them out. Sketch the following graphs, labeling the turning point and the y-intercept. Have a try. Okay? Alright, next page. One more page to go. Okay, good already. Okay, let's move on. Alright, next page. So things get a little bit harder where you have to do true transformation, both vertical and horizontal. Let's look at this. The -3 moves to the left. Oh no, right. And the -2 goes to the down. Down to right 3. Okay, let's do that. 1, 2, 3. Right 3, down 2. There we go. That's your vertex. And then let's work out the y-intercept before we draw, so we'll know where it crosses on the y-axis. Let's work out the y-intercept. That's when x is 0, y equal to 0 minus 3 squared minus 2, which is 7. So it crosses at 7. Okay, we're ready. Let's draw using a purple pen. So you go like this, making sure you cross the y-axis at 7 and go up again. Right, not the... Okay, like that. Maybe you should go a bit higher. Okay, anyway, so that's your parabola. Make sure you label the turning point. So label the turning point means you're going to write next to the vertex, write down 3, -2. Labeling the turning point. I'll call the vertex. I think that's all. Try the next one. You don't really need to find the x-intercept, but you can if you want to. Alright, thank you. Alright, good. Continuing. Try the next one, please. And the more things you do by yourself, the better you become, the more confident you become. Okay? So try the next one. Again, analyzing what does each number do to the graph. What does the +1 do? What does the +4 do? What does the minus in front of its bracket do? Okay? Once you master this, drawing parabola is very easy. Right. Okay, so we're going to go see the negative means concave down. You're going to shift the concave down parabola left 1 and up 4. Okay, let's try to do that. So you go, let me use a magic pen. Oh no, that's not this one, magic pen. So you go this way, you're going to go left 1, go up 4, right? So you end up somewhere here, right? So you can sort of get a rough picture where it is straight away. Alright, so let's use the normal pen. And let's get it up there. Okay, good. So x and y. So go left 1 unit. Go up 4 units. Like this. And you need to make sure you cross on the right place. So let's find the y-intercept. That's when x is 0. Now be careful here. When it's up to 0, put the negative outside of the bracket. 0 plus 1 square plus 4. Notice that when you square, you do not square the negative. It becomes -1. Because the negative is outside the bracket, doesn't get squared. So the answer is 3. So cross the y-axis at 3. Now let's draw this. Go like that. Just concave down. Okay. The question didn't request that, but let's find the x-intercept as well to make it more complete. X-intercept, that's when y equal to 0. And then what we're going to do is put 0 there. Now this time, how would you solve for x? Would you have to expand it? You don't have to because it's already a perfect square. Move this term to the left. So you end up getting x plus 1 squared. Notice it become positive. The negative become positive equal to 4. And like before, you go square root plus or minus 2. So therefore, x can be 1, could be 2 minus 1 or -2 minus 1, which becomes 1 or -3. 1 or -3. Okay, so the parabola is complete, showing the y-intercept, x-intercept, and the vertex, which I forgot to label, labeling the vertex 1, -1, 3. Let's do that. -1, -1, 3. All right. All right, cool. Okay, question. Actually, -1, 4, sorry. Let's go undo. -1, 4 is the vertex. All right, okay, let's do the last question, the last challenging one. Now, I want to be able to work out the formula for this parabola. So find a rule for this parabola with the turning point 0, 1 and the point 1, 2. So you have to write down what it looks like. So let's write down the general form. The general form of a parabola is y equals to ax plus k squared plus h. Now from the vertex, I could see that the k and h value can be figured out. So therefore k must be 0. Okay, thank you. All right, k must be 0, isn't it? Because you didn't shift right or left, and the h is 1 because you shift up 1 unit, right? So now that means the equation becomes ax squared plus 1, okay? Now, the next step is we're going to find a. Now, a doesn't have to be 1, could be 2, could be anything. So how do I know what a is? We have to substitute that point in 1, 2 into this equation to work out the value of a. So put 2 into y, put 1 into x. So you end up getting a times 1 squared plus 1, right? And once you substitute it, you'll get a plus 1 equal to 2. Therefore, a must be 1. So now we found the equation. Therefore, the equation becomes y equal to x squared plus 1. So that's the step you use. All right, so we've done everything. We know how to draw the graph of a parabola, finding the vertex, the y-intercept, and we'll also know how to find the equation of the parabola giving a graph. That will help you to do any question in the textbook. Next lesson, we'll continue to draw other types of parabola. Okay? Start the exercise 9B today.